Welcome. This is our study guide from the book. As you can see, the book is here. I'm here. We're all here. Let's do it. Write a congruency statement for each triangle. So a congruency statement is which triangle is congruent to which. So we got to do our little triangle. The first triangle we write, doesn't matter what order we do it in. So we can just do P-A-L because we're all pals. And triangle. So this is where we have to actually match it up. So P is going to match up with A. And then A here is going to match up with P. And then Y is going to match up with L. Alright. Next one, congruency statement down here. Again, the first triangle we can order in any order we would like. N-O-E. It's like almost Noel. Kind of cool. And N is going to be in between the two congruency and the one congruency, so it's going to match up with S. O is going to actually match up with O. And E is going to match up with E. Okay. Let's go ahead and move on to the next two questions. So we'll move down. Okay, so which postular theorem could you use, if any, to prove these two triangles congruent? If not, say not enough information. So we'll stop right here and work on these ones. Right here I see that they share a common line. So we have side, angle, side, which is super sassy, yeah. This shares a common side as well. Across from the 90 is going to be the hypotenuse. And then we have the legs over here and here. So this is going to be by HL. Over here it looks like we have an angle and a side, but we have no other information, so this is going to be not congruent. And then this last one here, they have two sides and then they share a third side, so this is going to be side, side, side. Okay? So moving on. Number 7. Oh, dang, I should have fitted that one in. Anyways, this last one here, we have vertical angles. So we get angle, side, angle. And a living legend just literally walked in the door as I was doing this film. Austin Whitsett himself. Austin, say hello to the people watching the video.
What's up, people?
Okay, so we've got through 7. Let's go through the last ones. Okay. Back to the top. All right. Name all the pairs of corresponding congruent parts. Okay, so I'm just going to do this by talking. Basically, C is going to match up with H, E is going to match up with D, and O is going to match up with F. And then you can do the segments like CE is going to match up with HD, EO is going to match up with DF, and HF is going to match up with CO. All right, on this one we're finding the value of X. These two triangles are congruent by angle, side, angle. And since they're congruent by angle, side, angle, we can show that this piece and this piece by CTC are going to be congruent. So we get 3x equal to 108. And then all we have to do is go ahead and divide to make sure that goes in evenly, which it will. And that goes in 36 times, so x equals 36. And there's that. Number 10, it says name a pair of overlapping congruent triangles. In each diagram, state whether the triangles are congruent by side, 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 angle, side, angle, side, angle, 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 side, or HL. As you can see here, they're going to go ahead and share a couple pieces, but we want to go ahead and write them separately. So what we can do is I'm going to just draw them right over here real quick. Boom, there. And then the other one's going like this. Okay. So we have F here, C, and E. And then this one's E, D, and then F. Okay. So they're given that these two sides are congruent. It says CF and DE is congruent, so yeah, we took care of that. It says CE and DF are congruent, so CE is right here and DF is right here. And then they actually share EF. If you look at the picture, they share right there, so these are shared. And that's going to be side, side, side. So number 10, side, side, side. Let's scroll down and take a look at the next problem. Okay, so taking a look at these two triangles, we can separate them as well. I'll do this over here. We have more space. It's a horrible looking triangle. It's all good. Okay, so we have ART. And then we have triangle TSQ. It tells me that RT is congruent to QT, AT is congruent to ST. Okay, then we look here. Frog in my throat. Embarrassing. My face is turning red. I'm okay. You notice that they share angle T right here. So in our picture here, we can show T is congruent to T. So this is going to be side angle side, or SAS. And that's number 11. Take a look at number 12. Isosceles triangle ABC with a right angle B has point D on AC. So we got to draw a picture here. Whenever I do a right isosceles, I make sure that I get an angle that actually looks 90. So this would be angle B. So here's A and then C. And it says there's a point D that's going to go ahead and bisect this right down the middle. And that's going to make a 90 and a 90. We know that these two segments are congruent because it's isosceles. These two segments are congruent because they're shared. And we can actually prove that these two triangles are congruent, so they are congruent triangles. And knowing that these two triangles are congruent, we can prove it congruent by actual HL. So we have the hypotenuse here, and then we have a leg. Okay? Okay, let's look at the last two problems. They're proofs. I'm just going to go ahead and explain them, then you guys can fill them in. It says AT is congruent to GS, which is marked here, and they're also parallel. So we have a congruent segment right here in the middle, so we have two sides. Because of the parallel lines, we also have alternate interior angles, and that gives me side, angle, side. So this is going to be proved by using SAS. If we look at the next one here, we want to go ahead and use our triangle congruency and then CTC to help prove this one. I'm in the middle of a video recording. Yep. This one, LN bisects OLM. Here's OLM right here, so I know those two angles are congruent. And then it says it also bisects this angle down here, so I know those angles are congruent as well. And we share a common side. So we're going to prove these congruent by angle, side, angle. Once we prove them congruent, then we can use CP, CTC to prove the side ON is congruent to MN. All right, thanks guys.